This is a lecture on 9-2, testing the difference between two means of independent samples, t-test. Now the difference between a t-test and a z-test is with a z-test, the population of the population standard deviation is known. Using a t-test, the standard deviation of a population is unknown, so you're reserved to use an S, which is the standard deviation of this sample. So the assumptions for using a t-test is you must use, so this is a two-sample t-test. So 9-2 talks about a two-sample t-test. The assumptions are you have a two independent random samples. N does not have to be the same in order to run this test. If n is less than 30, population is approximately normal. And then you can go ahead and use a normal t-curve. So the test statistic that is given to us within this test so the test statistic is now a t because we're not running a z-test, we're running a t-test. It is a slightly different normal distribution that has a larger variance, and therefore the notation is slightly different. Now the formula does look very similar, so you're finding the difference between the sample means, the difference between the hypothesized means, that's a 0, and then instead of a sigma you now have an S, which is a standard deviation of the sample, and the formula looks a bit on the ugly side. Now this is what's programmed under a two-sample t-test. It's this formula. Now a t distribution comes in with the degree of freedom. The degree of freedom stated in the book, it says you must take the degree of freedom that is equal to the smallest between n1 minus 1 or n2 minus 1. Now if you do this on a calculator, the degree of freedom has a more elaborate formula than that, which is calculated. So I'm going to write this down. The degree of freedom is calculated. And we're ready to take a look at the first example. A study was done to see if there's a difference between the number of sick days men take and the number of sick days women take. So we are comparing men versus women. You have to call somebody sample 1 and somebody sample 2. Usually the first one that's mentioned in the problem is sample 1, and the second one is going to be my sample 2. A random sample of 9 men. So that means that they gave us the number of men, so n sub 1 is equal to 9. And found that the mean of the number of sick days taken was 5.5. So the sample mean was 5.5. The standard deviation of the sample was 1.23. So that's this sample. And this is how you know you have to use a t-test. It's because they say the word sample. A random sample of 7 women. So now we have n sub 2 is equal to 7. Found that the mean, so the mean of that sample is 4.3, and a standard deviation of the sample is 1.19. So this is my sample number 2. 7, 4.3, and 119. Very important to label everything the way it's supposed to be labeled. Can it be concluded that there is a difference in the means? So the word difference refers to the two-tailed test. So we can go ahead and start this. The null hypothesis is mu1 is equal to mu2. We are talking about inferencing about a mean, and in this case we're comparing two means. So the notation is mu1 is equal to mu2. The alternative hypothesis is mu1 is not equal to mu2. That would refer to the word difference. What we're going to be running is we're going to be running a two-sample t-test, two-tailed. The necessary statistics are outlined, and we can go ahead and start the test. Under stats, go over to tests. What you need is you need now a number 4, which is a two-sample t-test. Again, you have a choice between data or stats. We are given statistics in this one, so I'm going to choose statistics. And start entering. 5.5 is my mean for sample 1. 1.23 is the standard deviation for sample number 1. 9 is the number of entries. X sub 2, so this is your X bar sub 2. The mean of the sample number 2 is 4.3. The standard deviation is 1.19, and the number in your sample is 7. I choose the not equal to sign to indicate the two-tailed test. Under pooled, choose no if you have that option. We do not have pooled data. It is something that we do not study this semester. And then we calculate. The calculated values, let me move this a little bit further. The calculated values will be the test statistic, which is at 1.97, the p-value, which is at 0.0, and then it's a 698, so it's awfully close to a 7. And then right underneath it is the degree of freedom, which is being calculated at 13.25. So this is the type of a curve. This is the type of normal curve that we're going to use. It falls under the degree of freedom of 13.25, whatever that means. It is the larger the degree of freedom, the closer it actually looks like the standard normal curve. So that's what that number represents. It's how far away it is from the standard normal curve. Everything else that your calculator spits out is the statistics that you already have written down as the necessary statistics in order to run the test. There's nothing to check. There's no conditions that need to be checked because we do assume independence and normality for all of the problems in this book in order to even do any of these tests. And at this point, we just need to locate the p-value and write down the final conclusion. So the alpha is given to us at 0.05. Notice that 7% is larger than 0.05. So what you will see is the result of your test is do not reject the null hypothesis. Do not reject the null hypothesis. Can it be concluded there is a difference in the means? Since we did not reject the null hypothesis, that means that the null hypothesis does state that mu1 is equal to mu2. And so this is what we say. Not enough evidence to state that there is a difference between the number of sick days men take versus women. So the sentence doesn't have to be elaborate, but it should reflect to the information that you're trying to prove without me physically going back to the book and necessarily reading the problem. Now, the second part is the confidence intervals. Notice this is a two-tail test. A two-tail test, running a two-tail test will be equivalent to running a similar alpha confidence interval. So the alpha that is being used in the previous example is alpha of 0.05, so 5% alpha. This would conclude the 95% confidence interval, having the same conclusion, meaning do not reject the null hypothesis, not enough evidence to state that there is a difference between the number of sick days men take versus women. We should see the same thing coming out of the confidence interval. Now the confidence interval at this point looks amazingly horrible. It is programmed under your two sample t interval. You do take the difference between x1 and x2 and then add and subtract this ugly looking error on this side, and you take the same thing here but add this same error. All right, so this is the interval that is programmed into your two sample t interval. What I'm going to do is I'm actually going to go ahead and run this on the calculator. You're going to go under stat, go over to tests, and what you should be able to find is somewhere on a bit of a bottom, I have under 0, you should locate a two sample t interval. Remember, you know you're using a t is because the standard deviation of a population is not given to you. You have to use standard deviation of a sample. You are given statistics, and notice, because you just ran a previous example, if you were following my lecture with the calculator, if you just ran this example, what you will notice is all of the data is already there. You have x bar with 5.5, S1 at 1.23, N1 at 9, x bar sub 2 at 4.3, S at 1.19, N2 at 7, and then you just need to adjust to make sure that it is 95% confidence interval. As far as pooled, it should still be no, and then you calculate. It will take some time to process the data because what it does, it needs to create the normal distribution that is necessary to run this test. So it needs to calculate that degree of freedom, and this is what you need to input as part of your work. The degree of freedom for this particular problem is 13.25, which is exactly the same as the one that you were doing for the hypothesis test. The x bar, s, and an n, that's all there. And the actual interval is negative 0.11, that number, up to 2.5123. So what this means is these are days, but notice the negative value on the left side tells me that mu1 is actually less than mu2. The positive number on the other side tells me that mu1 is greater than mu2. So let me write this down. This number tells me that mu1 is less than mu2, and this number tells me that mu1 is greater than mu2. How can you have mu1 being less than or greater than at the same time? Well, that means that there is no significant difference. Between the number of days men and women take for sick leave. So from an interval, you can tell the result of your hypothesis, of your two-tailed hypothesis. What you will see is you will see a negative on one side and a positive on the other side. If they're both positive, that means that there is a difference, and in fact mu1 is greater than mu2. If they're both negative, again, there is a difference, meaning mu1 is less than mu2. And if you see negative on one side and positive on the other side, there is no difference between the two means. This will actually end 9-2, and we will continue with 9-3 in the next videos.